Hello everyone, this is David, mobile developer. In this video I will show you how to use the repository pattern to be able to persist data from a remote API in a local database. Basically what I want to achieve is to be able to keep a database copy of the data I get from a remote API. That way I can access it faster. Also, this allows the application to be used without an internet connection. For that I'm going to use the Recipes API. I will leave the details in the video description. I'm going to fetch a list of recipes and I will show them in a list. I'm going to show you an example of the final app that I'm going to create. Take a look at the initial loading. Here's the list of recipes. If I click on an entry, I can read its description. Now I am going to stop the app and relaunch it. Note that this time there is no initial loading. The reason is because I have saved the data in a database the very first time that I have opened the app. Things I'm going to explain in this video. I'm going to explain what the repository pattern is and how to implement it. I'm going to make API requests using the DO package. I'm going to interact with the local database using the sqflite package. I'm going to write models faster using JSON serializable. Now, things that I'm going to leave out of the scope of this video. The UI that I'm going to use is going to be minimal. This video is not focused on creating a user interface. I'm not going to implement any data synchronization system. The reason is that there are several ways to do it, and it will be more appropriate to create a whole new video to talk about it. So, about the repository pattern. This development pattern is usually found in the scope of the clean architecture. In it, we find two basic elements. One is the data source. This component performs raw operations against data. An example will be a class dedicated to making calls against an API, or a data access object that performs queries against a database. The second element is the repository. This component articulates one or more data sources and decides where the data should flow to or from. In this particular example, we're going to consume this recipe API, in which we will get a list of recipes. For this, I will create a class dedicated to making these API requests. This class constitutes the first data source. In order to persist this data in the database, I will create a data access object that will be the second data source. These two data sources are going to be articulated by an object of type repository, which will decide which data source to use based on several parameters. This will be a simplified form of the typical repository pattern. I won't implement all of its classic abstractions. The reason is that, in my experience, this way of doing it is perfect for small to medium-sized applications. If you have to develop a very complex application, which is going to manage a large volume of data and on which several developers are going to work, I advise you to study the classic clean architecture after this video and learn more about it in depth. The first thing that I'm going to do is to create a new Flutter app. I'm going to call it Flutter Data Layer, and I'm going to open it in Android Studio. I'm going to get rid of all of this. We don't need the Cupertino icons. And I'm going to add the required dependencies for the project to run. So we need the DO package to make API requests. DO is a package that simplifies the way that API requests are done. So we need to write less code than if we were using the standard HTTP package. So in order to auto-generate part of the models, we need to add the JSON annotation. I'm going to add the path and the path provider. These are needed for the database to work. I'm going to add the provider package in order to create the UI. The sqflite package will allow us to interact with a local database. We need the build runner in order to auto-generate the models. The JSON serializable will actually create the auto-generated code. And the first thing that I'm going to write is the domain model, the recipe model, with which we are going to work with in the app. So the remote API returns a bunch of data. We only need a few of that data. We only need the ID, the name, the thumbnail URL in order to preview the recipe, and a description. Now I'm going to create the network model within the data folder. I'm going to create a network package. We will hold all the network classes required. So this recipe entity will be the actual model that the API is going to return. We're going to use the JSON annotation to auto-generate part of the code, and we need to write this .g.dart file, which will be the auto-generated class. We need to annotate this class with JSON serializable, so the package knows which class needs to be auto-generated. So here I'm writing basically the same variables than before. I'm going to pause here for a moment and explain you why I'm doing this and why I'm not using the same class. While this example is very simple and we could use the same class, I like to have separated models for each layer. So the domain models, network models, database models, those are different even if they have the same data. And the reason is because I like to keep them separated so they can evolve in a different way. So in a more complex application, those models will rarely be exactly the same. And we don't want to couple those layers one with another. We want to keep them as separated and isolated as possible to have a cleaner code base. And the way of doing it is by having separated models in each one of them. The thumbnail URL variable, it's called different in the remote API. That's why we need to use the JSON key to let the auto-generate tool to know. So this will be the method that we are going to auto-generate this from JSON method. And in order to auto-generate this class, we need to run Flutter pub run build runner build. And this runner will look for the JSON serializable annotated classes and will try to auto-generate the required code. So here we have the new auto-generated class, and here we have the method that we need, this from JSON, which is auto-generated. So this example is very simple, just a little bit of code auto-generated, but if this sample will be bigger or in a bigger project, this can help to reduce the development cost, because a lot of methods are actually auto-generated for us. So this recipe entity will be returned in a list. So I'm going to create now the response of the endpoint that I'm going to call, and this response will have a count, the number of elements returned, and the list of elements. I need to run the build runner again to auto-generate this new method. Now I'm going to create a new folder called client, in which I'm going to create the actual client that will perform the network queries. I'm going to create a custom exception which will hold the status code of the request and an error message. This will be useful when some error occurs and we need to know what happened. This API client will receive the base URL, which will be the endpoint base URL, and an API key. This is required to use the API. If you're going to use the same API, you will need to register and get your own API key. I'm going to create a method to return the list of recipes. And I'm going to wrap everything within a try catch. As we're going to use DO, if something happens, we will get a DO error. And if the response is not null and we get a status code, we can throw this custom exception that I just created with the status code and the message. If not, I'm just going to throw a generic exception. As I said, I'm going to use dio to get this list. And we need to write the endpoint URL. This API forces us to provide these two parameters. This is useful if we want to paginate the results. So I'm not going to do it in this sample, but I have an example of how to paginate results. I leave you the link to the video that I show how to paginate results obtained from a remote API. If you don't see the link in any of the corners of the window, you can find it in the video description. Also, we need to provide an options class. These two variables have to be in the header. And once we get the data, we just need to return the recipe list response that we have just created. The next thing will be to create a mapper class. This mapper will be responsible to convert the model of one layer to a model of another layer. So first I'm going to create another custom exception which will hold from which model we want to convert to which model we want to convert. So if something goes wrong, we will have the information of the source and the target models. I'm going to accelerate this part of the video since we're not doing anything special here. If you want to get a closer look, you can get the source code, which is in the video description. Next, we will create the repository. This repository will receive the API client and the mapper. And we'll get the list of recipes, map the results, and return them. Now the next part will be to create a file in which I will write the API key. So this file is not in Git, so if you download this project, you will have to create this file with your own API key. Next, I will create a presentation package to put all the user interface. I will create my app widget. which will have a multi-provider. I forgot to add the logger package. I like to use this package to write my logs, as it writes them in a more readable way. Now this multi-provider will hold all of the app dependencies, so from any widget we will be able to get any of those dependencies. And the material app will return a main screen which doesn't exist yet. And now we're going to create the main screen. So this main screen, the body will be a future builder, which will be the call to the repository to get the recipes. And if something goes wrong, I will return a simple error message. I will add a progress indicator to give some kind of feedback while the data is being fetched from the remote API. And when the data is downloaded, I will show it in a list. So each element of the list will be a list tile in which I'm going to display a small image of the recipe, and I'm going to show the name of the recipe. Next, I'm going to execute the app as it is now to see if it works. So the loading displays correctly, and here we have the list of recipes. Now I'm going to create a simple screen to show the description of each recipe. This screen will receive the recipe as a constructor parameter. And we can access this detail screen by tapping on each recipe entry. Now I'm going to create all of the database part. I'm going to create a database package in data. And the first thing that I'm going to do is to create the database model. So this will be an actual representation of the data that I want to save in the database. First, I'm going to write in these static const fields the name of the columns. And again, I remind you that I'm doing this just because I want to have each layer as much isolated as I can from one to another. So I'm going to write the fromMap method and the toMap methods. These methods will be required to read from the database and to write onto it. I'm going to move this into a new entity package within the database package. Now I will write the data access objects. First, I'm going to create a base DAO, which will be used by any DAO in this application. We're going to have one single DAO, but I always do this. So this class will have a method to retrieve the database instance. And I'm going to write the database creation query here too. If you want to have more details about how to work with a database, I will leave you a link in the video description that will guide you to the official documentation, which is very good and will explain you with details how this is about. Next, I will write the recipe DAO. Which will have a select all method that will retrieve the list of all the recipes saved. And an insert all method that will be used to store all of the recipes that I will receive from the remote API. Now we are going to refactor the recipe repository with the desired behavior that we want. I'm going to add the recipe DAO as a parameter. So first, this getRecipes method, the first thing that we should do is to fetch the local database to see if we have data. And if we have, we just need to return it. But first, we need to write more convert methods in the mapper just to convert from the domain layer models to the database models. But if we don't find anything in the database, we need to do the actual API request, save the result recipes, and then return them. Now, at this point, you will see that this is a very simple approach. What happens if the data changes in the remote API and we are returning wrong data? So here we could write a synchronization mechanism. As I said in the beginning of the video, there are several ways to do it. I am not going to do it now because it will require a whole video talking about what strategies can we follow. So I will leave just like that for now. So in order to the sqflite package to work correctly, we need to add this first line in the main Dart file, and I'm going to enable the logs if we are running the app in debug mode. I'm going to update the list of providers required. Now let's run this to see what happens. I'm going to add those breakpoints to see if the behavior of the app is what we want. So first call, it's correct. The data is now loaded from the remote API. Here we have the list. I'm going to stop this, run this again. And yeah, we are fetching the data from the database and return it. So I'm going to do a second test without debugging. I'm going to simulate more network delay just to see the effect of adding this local cache in the database. Uninstall the application. So there is no database, there is no cache. I'm gonna run this. Here we have the initial loading. And I'm going to stop it and run it again. So we should not have the initial loading again because the data comes from the database. And here we have. The behavior is exactly what we wanted. This is all for today. You can find the source code of this sample in the video description. If you have questions or suggestions, please leave them in the comments. Also, give a thumbs up if you find this video useful, as it helps me to grow this channel, and consider subscribing for more content related to Flutter and mobile development in general. Thank you for watching this video and have a lovely rest of your day.